Let's introduce our first speaker on this stream. Gerrit Grunwald is a software engineer that loves coding for around 40 years already. He's a true believer in open source and has participated in popular projects like JFX, as well as his numerous own projects. Gerrit blogs regularly at harmonycode.org and he's active member of Java community. He founded and leads Java user group in Münster. He is a Java 1 rockstar and Java champion. He's a speaker at conferences and user groups internationally and writes for several magazines. So please welcome our speaker. Hello, Gerrit. How are you doing?
Hey, I'm fine. So it's a little bit early here because I'm on a JAG tour in the US, so it's 3 a.m. So
Wow, that is indeed an early time to make a presentation, but it seems like you have a cozy place to stream from, so I hope it all
yeah,
will
it's a
work well.
hotel room. It will work.
I was looking through your bio, right? So you pretty much have seen the whole evolution from the baby steps of Java to the current state of the ecosystem, right? How it evolved and how it became what it is right now. If you're looking back at all those possibilities in Java platform, can you remember some of the moments that you were saying, hey, this is something so exciting that will revolutionize or make the programming in Java so much different than it was before?
Yes, and that was definitely JDK 8, which changed for me. Before JDK 8, Java was not that exciting anymore, so it became like mature and a little bit old-fashioned. But with JDK 8, I think it kept up with other languages like streams and this whole stream API that and lambdas and all these kind of things. And then the stuff that we saw after that, it's increasing its capabilities with each release, like we saw this week with JDK 21, where we now have virtual threads. So it is exciting. It's exciting to see that Java is, even if it's so old, it's still keeping up with the new features of other languages. So that makes it for me still my favorite language to code in.
All right. That's a great answer. Actually, yes, there were definitely quite a few moments where Java was introducing bits that were super exciting to work with. And now, without further ado, I'm giving the stage to you so you can start with your presentation whenever you're ready.
Okay, thank you. Yeah. So welcome to this presentation. It's called Welcome to the Jungle, Safari through the JVM landscape. And the reason for the title is that we have this OpenJDK project, which I will talk about, and we have lots of different versions and distributions out there. And this will or should hopefully help you to make the right choice to choose one. So my name is Gerrit Grunwald. I'm working for Azul as a senior developer advocate, and I'm also leading the Java user group in Münster and other stuff. So that was already mentioned. And so we just will skip forward to OpenJDK. Usually I ask people when I do that in a cinema or something, I ask people, so who is running in production, for example, on OpenJDK? And then a lot of fingers will rise. And then I usually tell them that is probably not right, because OpenJDK is in principle just the source code that is hosted on GitHub. What you use or what you run on is a build of OpenJDK, and that's a so-called distribution. And usually these have names. So that's a difference, right? So because when people come to the booth, when we have a booth at a conference, they come to the booth and then I ask them, so, oh, what kind of distribution do you use? Oh, I run OpenJDK. Oh, okay. And then you have to explain it. So it is a free and open source implementation of the Java Platform Standard Edition, or shortly Java SE, how we know it all. It has a website. It is here. You can see openjdk.org. You can find all kinds of informations like projects that's going on and other stuff on that website. And because it is open source, you can also find the source code available. And this is at GitHub, finally. I think it started with JDK 16. It became a GitHub project. So if you're interested in the OpenJDK source code, you can look it up here and you will find all the good stuff in there. But be aware, it's hard to become a contributor, just to let you know. But at least you can take a look at the code. So, and because it's an OpenJDK it's an open source project, it has contributors. And that's an interesting thing because we all rely on Java, or many of us. So this is the list of contributors that contribute to the OpenJDK source code. And you see very much in the middle, there is something like many individuals, because there are so many single people, also small companies, that really contribute code to the OpenJDK project that I couldn't list them here. So you see, we have really a lot of big companies on that list. You see, of course, Oracle, you see Red Hat, Microsoft, IBM, Intel, Alibaba, which is huge, Amazon, Azure, Bellsoft, lots of companies are on there. And that is a good thing, right? Because that means it's not a one-man show. And this is exactly what we would like to have. Because if a one-man show means you really rely on one company, and then they could dictate whatever they want. But this is not the case in OpenJDK. And so because all these companies have a really big interest in moving things forward, it's a really safe bet to use Java, even for future projects, because it won't go away easily, because all these companies rely on it, right? Which is great. So it also has a roadmap, of course. It's a huge project. And this is the old release cadence. And you see it starts with JDK 6, which was the first version of OpenJDK. It came in the very end of the JDK 6 lifecycle. I think with one of the last updates, it became open source. And then it took 4.5 years before we got the new JDK 7. And that was a big one. I dressed up my car for that. So I get a Java logo on the front of my car just because of finally we get JDK 7. Yay. So that feels like it's in the Stone Age right now, right? So that was 4.5 years between these two releases. And then it took another 3 years until we got to JDK 8, that was a really big one that changed a lot of things and made Java really more sexy, right? And then this release cadence didn't really work out, right? Because it really took a long time between those releases. It means you have to wait multiple years before you can test a new JDK. And the problem was once you got, for example, JDK 7, it took probably another year to update all your code in production before you can really use JDK 7, because you have to test a lot of stuff. And so they changed the release cadence, and also the JDK itself became modular. And that was a really good step. It was a little bit confusing in the beginning because instead of having every new version a couple of years apart, so now we have new versions every 6 months. And that was in the beginning a little bit strange, right? So now you can see we got JDK 21 on Tuesday this week. And these are all the releases that we got in between. So every 6 months, there is a new release. And this is cool because now you can test new stuff every 6 months. And that means the adoption of new features can be much faster and easier than before, because each of these releases don't contain that many features. So it's easier to test and to adapt to the new JDK version. I have to go to the basics, sorry, but there's a reason for that. So we have the JDK and we have the JRE, and the JDK means Java Development Kit. And usually I ask people who is running a JDK in production, and believe it or not, there are a lot of people using a JDK in production. Sometimes there are reasons for that. Usually it's related to debugging, but you shouldn't do that. You can do that in staging, but in production. And then people are blaming Java for being, the memory footprint is so big. Well, if you use a JDK in production, sure. Then there's the JRE, which is a Java runtime environment, and the name says it, right? So this is for run Java applications. It only contains the Java class libraries and everything you need to run an application, but it doesn't contain Java C, Java doc, and all these things that you need for development. So what it is the runtime environment contains the Java virtual machine and the class libraries, where the JDK contains the JRE plus, like I already mentioned, the Java C compiler, the debugger, and the Java doc. So the recommendation is up to JDK 8, you should choose the JDK for development, the JRE in production. Well, up to JDK 8, what is from JDK 9? Well, there's something called JLink. And it's really surprising to me that really just a few people even know it, even if it's in the JDK since JDK 9. So what it is, it's a tool to create a custom Java runtime image. And what you usually can do is there's another tool that comes with the JDK since JDK 9, which is called JDEPs. So with this tool, you can just run it against your jar files, for example, and it will tell you all the dependencies that you use within the JDK. And with this information, you can use JLink to build a JRE that is tailored to your application. So that means it only contains the parts of the JDK that you really need. And if you don't need a lot, like in microservices, then it can be really small compared to a JRE, right? So the JLink images are smaller than JREs. So if memory or memory footprint is a concern, then you should really take a look at JLink. And you don't have to download something. It comes with a JDK. So take a look at it, and if you can, use it. It makes sense, especially in containerized environments. And now the interesting thing, distributions. We have lots of them. And I will start with the builds of OpenJDK. And this is the builds of OpenJDK. On the upper right, you see Samaru and Samaru certified. This is the one from IBM. It's not really a build of OpenJDK. It's based on the IBM implementation of the JVM spec, right? So that means they created their own JVM, which is OpenJ9. But I put it here because you can compare them. OpenJ9 is a little bit different, but it is totally compatible to the Java spec. So we just keep it like that, right? So just to keep in mind, this is not really OpenJDK, but we treat it like that. Then you see these two little ones with a cross. It's the adopt OpenJDK and the OJDK build. Adopt OpenJDK died with 1602. And then they transferred the project to the Eclipse Foundation, and it became Tamarin. It's not the same distribution, right? Even if they claim it is, it's not. It's a different one. But it doesn't matter. So adopt OpenJDK, you shouldn't use that, right? There's no support for this distribution anymore, because I know still some people use it. And like I said, it stopped with 1602. OJDK build, that was the community build of the Red Hat JDK. And this one died with 1702, as far as I remember. So it's not supported anymore. So you can download it still from GitHub, but like I said, it stopped with 1702. And then you see all these others. And you might find some really things that you never heard of before, like Bisheng. This is from Huawei, or maybe Kona, which is from Tencent. These are companies coming from Asia, and they are really big in Asia. Even if we don't know it, doesn't mean that they are not successful. Or Alibaba Dragonwell. This is huge, right? But we don't know it. But these are also a valid distribution that you can find on the market and download and use. So that's 20 different ones, right? And this is just the builds of OpenJDK, because we also have builds of GraalVM, right? So it's, GraalVM, and these are the builds of GraalVM. So you have Glue on GraalVM. This is mainly for mobile applications and embedded, and also desktop, based on JavaFX. So it uses JavaFX. And then we have GraalVM Community, which was the formerly known GraalVM CE. And then there's GraalVM. That was GraalVM Enterprise. They changed it recently. And then there's Liberica Native Image Kit, is from Belsoft. It's their implementation of or let's say their build of the GraalVM community. And there's Mandrel, which is the Red Hat build of GraalVM. And all these builds, except the pure GraalVM one, are based on GraalVM community. And the reason for that is that GraalVM Enterprise was not for free. It is now, but it's only for 3 years. So that means as soon as a new long-term support version will come out, like LTS 21 this week, there's 1 more year you can use it for free, the 17 one, and then you have to switch to 21. Otherwise, it will fall back from the free license to the OTN license. You have to keep that in mind. And also the source code of GraalVM, the enterprise version, is not available, but only the community source code. That's the reason why all the other distributions that you see here are builds of the GraalVM community stuff. And that also means they don't have all the features For example, profile-guided optimization, not available in all of those, except just GraalVM. So the question is, which one to choose? To answer that question, we have to find some differences between them, right? So I tried to come up with a list, and in this presentation, I do a reduced one because my flight is going at 6 and I have to run after this presentation to get to the airport. But still, we can differentiate them between term of support, I will come to that, updates, compliance, cost, and performance. And usually I also have features, but we will skip that one. Term of support, what does it mean? We have different kinds of versions out there. So you saw with the new release cadence, like 9, 10, 11, 12, and so on, we have so-called short-term support versions, and the name already gives you an idea of what it means. And we have LTS releases, which means long-term support versions, right? And how it works is that Oracle came up with this strategy, and every other company follows this strategy. It doesn't mean that every company that has an LTS release gives you support in the same way that Oracle does, for example, right? So I just know from Azure, we have sometimes versions that we support longer than Oracle does, right? So this is just that you are aware of that. And now we see here all these different JDK distributions that are available. And all the white ones are these short-term support versions. It's only 6 months between them, and you will only get support for 6 months. So that means, if, for example, if you use a JDK 12 in this case, because with JDK 12 there came something like JPackage, which is a tool to create native packages from Java applications, especially for desktop. So you say you would like to use that. You switch to JDK 12. 6 months later, JDK 13 came out. That means support for JDK 12 stopped. There haven't been any more updates for that, right? Security patches. To stay secure, you had to jump to JDK 13, and then 6 months later to JDK 14, and so on, until you get to JDK 17, which then, that's a long-term support version, that gets support, that means updates up to September 2029. So this is the thing that you have to keep in mind. You shouldn't really run STS releases in production because you won't get really support for that. It means, in principle, the most important part, vulnerability fixes. And that is the reason why that we have these long-term support versions. And 21 is also one of these long-term support versions. And the cadence between them switched from 3 years now to 2 years. That means every 2 years we get a new long-term support version. And this week, Oracle also announced that the long-term support, this is extended long-term support, for JDK 11 was increased to 2032, right? So this, you are still on the safe side if you use a JDK 11. So that means STS releases only get updates for 6 months. Keep that in mind. LTS releases get updates for years, and that can vary between the distributions. So, and the other thing is, not every distribution provides an STS and LTS release. So you will find distributions like, for example, Microsoft. They have their own JDK builds now, mainly to run it on Azure, and they only have long-term support versions. So that means they have 11, 17, and probably they will get 21. They don't have the ones in between, where others have all these STS releases, like also Oracle does. So you have to, this is one point where you can make a difference here. So if you would like to test things, then you probably would like to use a distribution that has all the STS releases so that you can test all the new features in development before they go into production. So recommendation, in development, you can choose whatever you like, but in production, stick to a long-term support version, which is just to be on the safe side, right? The next thing that is important to know is updates. And the reason why this is important is we have different kinds of updates, and usually people don't know about it. So there's the so-called critical patch update, or also CPU. And when I ask at conferences who knows a CPU, then it's maybe one person, maybe two. And one of the main reasons is you won't get them freely on the internet. So this is something that you usually only get if you pay for Java support. then you will get the critical patch updates. And this is also the reason why they are not available for free for download, because they contain different things, and we will come to that. The next thing is PSU, which means patch set updates. This is the stuff that you usually can download from the internet. So if you download the new update for, let's say, 1708, then this is probably a patch set update, a PSU. So what is it? Right. So if we have a CPU, then this CPU only fixes vulnerabilities and critical issues and nothing more. That's it. It's a critical patch update. If we have a PSU, the PSU contains the CPU, and then it adds fixes for non-critical issues, and it also can introduce new little features. These are not features like Loom. This is small stuff, right? So, but it can, and it happens. So it contains more than the CPU, right? And introducing new stuff can lead to new issues easily. And I have an example for that. So we get them 4 times a year. It starts in January. And as an example here, for example, we start with 1701. And you see in the top row, you see the PSU, which contains the CPU. And in the bottom row, we see just the CPU, the critical patch update. In January, we got 1701. Then in April, there was 1702. And it means the PSU got all the critical fixes, and it also got non-critical fixes and some features, where the CPU is based on the former PSU and only contains fixes for 1701, right? So you already see that the CPU is always one step behind when it comes to these non-critical fixes and also features, right? They always come with the next one. The reason for that is it gives you another 3 months where the 1701 was already running somewhere in production, and maybe new problems occur, and then they can be fixed for the CPU 1702. This is the reason. And then it goes on, right? 1703, the PSU get the new stuff, the CPU get just the fixes for 1702. And then in October, the last one. And this is the cycle for the PSU and the CPU updates. So CPU updates are 3 months behind PSU updates, but way more secure because they have additional time where the PSU was widely out in production everywhere, and then we can fix stuff in there. This is also the reason why you pay for Java, some companies, right? Because for them it makes sense, especially banking, trading happens everywhere where you run mission critical stuff and you would like to make sure everything's secure. They usually buy the CPU releases. And the patch set updates, I mentioned that already, they are available from nearly all of the different distributions, right? If you download somewhere, let's say from Bellsoft or even from Zool or from Oracle or wherever you get the updates from, these are PSU updates, patch set updates. Right? The CPU updates are only available from Azure, Bellsoft, and Oracle. No other company will do that. So, and you don't see them on the websites. On the older ones, you found them on the Oracle pages when JDK was free. There you could see the different ones, and I have an example. So the recommendation is, in development, you can use whatever you like, but in production, if you run mission critical stuff, think about using CPUs because they are more secure, okay? Why CPUs matter? Well, there was one example. In PSU, so the patch set update 8U252, it introduced a change that prevented Hadoop cluster and Solr from running. So that means if you install that in production, suddenly Solr or Hadoop didn't work anymore. If you install the 8U251, which was the CPU, this only contained the fixes from the previous PSU, which was 8U242. And this didn't introduce these new features, right? And that didn't break Hadoop cluster and Solr. So you see, there are reasons to use CPU updates. It really depends. Compliance, the next big thing. TCK, probably most of you heard of it. It's the Technology Compatibility Kit. It's licensed by Oracle. It was originally introduced by or developed by Sun Microsystems, and then now the intellectual property is now licensed by Oracle. It contains, for example, for JDK 11, more than 120,000 tests. And these tests are defined in the JCK, right? So it's a TCK, Technology Compatibility Kit, and then the tests in there are in the JCK, which is the Java Compatibility Kit. And this is part of the TCK. So how can you get access to the JCK? So it is available at no charge, and you just must meet the terms of the OCTLA, which is the OpenJDK Community TCK License Agreement, which means, in short, paperwork. And you also must sign the OCA, which is the Oracle Contributor Agreement, more paperwork. So, but you can do that. So that means you can apply for getting the JCK, and you can get the source code of OpenJDK, you can build it on your machine, and then you can take vacation and run all the TCK tests on your machine. And when you come back, you have a TCK licensed build of OpenJDK. And then if you would like to distribute that, then you have to think about, we also have to do that for not only Mac on ARM, but Mac on Intel. You have to do it for Windows, different versions, different architectures. You have to do it for Linux, different distributions. For all these kinds of things, you have to run all the tests. And only then you can name it Java SE compliant, right? So this is, or compatible. So this is the TCK. It tests really the implementation of the Java spec, which is a good thing. And the reason for that, the reason why the TCK is a good thing, is if you run, for example, on Oracle JDK, and you would like to change to whatever build of OpenJDK, then as long as both of these JDKs are TCK compliant, you can just exchange them. And the TCK makes sure that it will work, right? So there are some tiny differences when it comes to desktop applications, because OpenJDK doesn't really support stuff like specific fonts that have to be used in Oracle JDK, especially in the older versions. They had some fonts licensed that have not been part of the OpenJDK and stuff like that. But in principle, in these days, you can just exchange JDKs if they are TCK compliant. So, and then here we have a list of all distributions that are TCK compliant for JDK 8. And I make this difference between JDK 8 and 9 and above, because you will find stuff like Dragonwell in here or Bisheng. So that means if you have a JDK 8 version of Dragonwell from Alibaba, this is TCK compliant. You can change with all these and it will work. Your code will work. If you go to JDK 9 and above, then that changes. You see there's no Bisheng anymore and also no Dragonwell. So that means even if a distribution claims to be TCK compliant, doesn't mean all their versions are TCK compliant. You really have to check that. You can't just simply trust and say, oh yeah, they say all my builds are TCK compliant. You see it's not the case, right? You have to be careful with that, because if you don't have the TCK compliance, means maybe your JDK build breaks something in the TCK. And that can lead to the fact that if you run code on that JDK, it can break your application, right? So this is something you have to be aware. And other things that are maybe interesting to know are stuff like, if you would like to run the TCK stack on your JDK build, you need stuff like a sound card, you need a printer, you need a CD-ROM, you need a DVD-ROM, you need in principle everything that is supported by Java, because these tests cover all of it, right? So it's a lot of stuff. And this is also one of the reasons why you have to pay for some distributions, because companies have to prepare for that, right? So we need the hardware to run the test, we need the people to support the hardware and running the tests and all these kind of things. All right. Then there's another test, which is a little bit newer. It's the Adoptium Quality Assurance Vitality and Speed Test Suite, which is also called Aquavit. It's by Eclipse. It came with the Adoptium project. So it means with Xamarin, which is their distribution. And where the TCK tests the implementation of the Java spec, the Aquavit tests more the overall performance and security stuff of the JDK for production use. So it's a collection of over 350,000 tests. It's designed to test real-world utilization patterns, and it's a suite of security and durability tests. And here's a list of distributions that support or that are compliant to Aquavit. You see, it's only 5. And again, For JDK 8, you see Bisheng and Dragonwell. If we go to JDK 11, because this is not available for 9, it's 11 and above, there's no Bisheng and no Dragonwell. The reason for this is to become Aquavit compliant, you need to have the TCK, right? If you are not TCK compliant, you can't get the Aquavit compliance. So it's relying on TCK in this case. And that's the reason why we don't see it here for Dragonwell and Bisheng in JDK 11 and above. And you see it's only just 5 companies, they really pass this Aquavit compliance test. And you will find them on the Adoptio marketplace. You can download these distributions from there. Recommendation, development, whatever, production, make sure it's a TCK based or TCK compliant JDK build, right? So this is really absolutely important, I think. You don't want to break your application just because you use something that is not TCK compliant. Cost, another factor. We are so used to use everything for free in the Java world, which is sometimes good and sometimes bad, because people just, it's not, in the meantime, it's not, people just assume that everything is for free. Well, why should I pay for it, right? These people, they do it and I just use it and I make money out of it. So why should I pay for open source, right? So yeah, but that's a different story. So you see, all these distributions you can use for free, also in production, no problem. You see at GraalVM and Oracle JDK, I made this little asterisk because there's this changing license thing, right? So after 3 years, it will change back to OTN, and then you have to pay for the number of employees in your company, which might be a big difference. So it might be more expensive. So if you are using GraalVM or Oracle JDK, be aware that you really read the license terms, because they are different and they can change in the future. But all the other ones you can use for free in production without paying for it. Well, that's a good thing, but sometimes you have to pay for distributions, and there are also reasons for that. So there's one of those is Azure Platform Prime. It's one of our own JVMs. And the reason for that is that this is not just a build of OpenJDK, but it contains a different compiler that we developed. It depends a different garbage collector that we could develop, and also other features that you won't find in OpenJDK. And then there's IBM certified, Samaru certified. And the reason for that is that I told you that the JC key is in principle available for free, but unfortunately, because Samaru is based on OpenJ9, which is not really OpenJDK, Oracle said, well, you know what, IBM, you have to pay for the TCK. That's the reason why we have Samaru and Samaru certified. And for Samaru certified, you have to pay because IBM has to pay. So this is the reason. And then we have the GraalVM thing and the Oracle JDK. I mentioned that already. This is based on the number of employees once they fall back to OTN. So you really have to read these license agreements. We all know the Oracle stuff is sometimes confusing. You can check it out, but be aware, could be expensive. Okay, next point, performance. Right. Performance, everybody's interested in performance, of course. Yeah, what's the fastest JDK? Well, there's first of all something like a baseline performance. And oh, surprise, surprise, because they are all built on OpenJDK, what do you expect? I mean, this is the same source code. Yes, you can add some tiny features here and there to make it a little bit faster, but this is not groundbreaking. So it doesn't really matter as long as and you see I also put in GraalVM stuffs here, right? So because they also contain a compiler that is a JIT compiler. So you can run Java code also on GraalVM and not using native images. And the performance is more or less the same for all of them. So you won't find really huge differences. So if you think, oh, I will change to Microsoft JDK because it's way faster. Oh, it's not, right? So this is all more or less the same. So, which is also a good thing because you can choose, it's up to you and you won't lose performance, right? Like I said, more or less the same with some exceptions. High performance, yes, there are some JVMs that are built for high performance, and therefore we have to take a short look in the JVM. So the JVM, it has these 3 parts, like the class loader subsystem, the JVM memory, and the execution engine. And within these parts, we have different things like in the class loader, loading, linking, and initializing. And in the JVM memory, there are different parts like the method area, the heap, the stacks, the PC registers, native method stack. And then in the execution engine, we have the interpreter, compiler, profiler, garbage collector, and then also stuff like native method interfaces or JNI or native method libraries. So you see it's quite a lot of stuff in the JVM. Why is that interesting for high performance JVMs? Well, if we take a look at the execution engine, then we see it contains all these parts, and you see the JIT compilers and also the garbage collector you can exchange without losing the TCK compliance, because this is really something how you compile code or how you do the memory management. And if you exchange it, it will still pass the TCK, so you can do that. So, and that's what some companies do. So first of all, I already told you, we have this Azure Platform Prime where we exchange the C2 compiler with our own one, which is called Falcon, and it's based on LLVM. And then we also have our own garbage collector, which is called C4. And in this combination, it's really good for high performance applications. So you can, depending on the application, you can reach up to 50% more performance using Azure Platform Prime compared to OpenJDK. And then there's Oracle GraalVM, which is the formerly Enterprise Edition. And they also exchanged the compiler. So the C2 compiler is here like rewritten in Java and has also more optimizations and stuff. So this also produces faster code than the typical OpenJDK builds, right? So these two I would count as a high performance JVMs that you can really use if you have a high demand for high performance or short latency stuff, right? Features. Oh, I have it in my slides, which is good. Let me check. Oh, I don't have a lot of time, but we can go through that. There's Amazon Corretto. It comes with SnapStart, which has a faster startup to crack, which is checkpoint restore. And they name it Firecracker, which is micro JVMs, especially good for Lambdas. If you use Lambdas on AWS, you probably should use SnapStart with Corretto. Then we have Alibaba Dragonwell. I mentioned that already. This is the Alibaba JDK or build of OpenJDK, which they use for Alibaba Cloud, which is huge in Asia. And they have standard and extended edition, JWarm-up. It's an experimental faster startup by caching compiler optimizations. They have an elastic heap that returns memory of the Java heap to operating system. And they have WISP2, which is stack-full symmetric coroutine at JVM level. So they have quite some things in there. Most of it is made to make it faster on their cloud environment, like the Corretto stuff. Then we have Tencent Kona, which is specialized on ARM. And they have Kona fibers in JDK 8 and 11. That's a coroutine which is compatible with Loom. So they have these virtual threads already in JDK 8 and 11. And it didn't came now. It was there already last year. And they claim it's faster than the Loom implementation. So they have tests on their website where they show it's faster. And they have it for JDK 8 and 11. And they also implemented ZGC for ARM, the garbage collector. We have Bells of Liberica. This is a build of OpenJDK that you can get also with a bundled JavaFX version. So if you're into the JavaFX area, then this is one of the distributions that you can use, because then you don't have to install JavaFX separately. There's also Bells of Liberica NIC, which is the native image kit. This is the build of GraalVM. And this is the only one that also comes built with JavaFX. So if you would like to create desktop applications, you can use Bells of Liberica NIC to do that, native desktop applications. Yes, I mentioned that here. Then there's Gluon GraalVM. That is especially focused on JavaFX. And you can do native desktop applications with that. You can do native Android applications and native iOS applications. And I did a lot of this stuff, and it's really fast. Right, so if you would like to try it, it's really easy to do. So you can use GraalVM to create native iOS or Android applications if you like. Then we have Oracle GraalVM, mentioned that already, Community and Enterprise Edition, Polyglot VM, support for Java, JavaScript, Python, R, and Ruby. And it has a Graal JIT compiler, which is the replacement of the C2 written in Java. And it also has this AOT compiler that can create native images, which is ahead of time compilation. IBM Samaru, totally different thing. There's a community and certified edition. We saw that it's based on OpenJ9, which is the IBM JVM. And usually this has a faster startup and a lower memory consumption than the OpenJDK implementation. It also has an AOT compiler, which is not for native images, but they pre-compile stuff dynamically. So the AOT compiler figures out what's used quite often, and then the next startup, this pre-compiled stuff to increase startup time. They have Instant On, which is also checkpoint and restore on the JVM for faster startups. And they have a JIT server where you have, in principle, you can think about having the compiler somewhere on a server, and then the services, just instead of compiling it locally, they ask the server for the compilation. And once the compilation is done, the next time you ask for it, it's directly there. So you don't have to compile it every time. You just have to call the JIT server for the compiled code. We have Microsoft JDK. They have something called No Escape, which is an experimental feature to decrease latency and improve throughput, mainly for Azure. We have Azul Zulu, which is our own build of OpenJDK. This is available with also bundled with JavaFX if you would like. We have Azul vulnerability detection in there. So that means we can detect vulnerabilities at runtime in production. So because this is in the JVM, so instead of using an agent, which might be slower, so the JVM itself detects that, because it calls a so-called forwarder, and then with all the classes that have been loaded. And the big advantage here is that we can tell you, yes, you use a vulnerable dependency, but you never really load the classes. So because the JVM knows if the classes have been loaded, so that means we can tell you if you have vulnerabilities and also if you use them or not, right? It also comes with crack. So this is coordinated restore at checkpoint. So we invented that 3 years back, and it's an OpenJDK project where you can run the JVM, including your application, stop it, save the complete state, and then you can restore from that state within milliseconds, and then it's in the range of native image startup times. And then we have Azure Platform Prime. I mentioned that also. This has all the bells and whistles, which is the Falcon JIT compiler. It has a C4 garbage collection. It comes with Ready Now, where because we have our own compiler, we can just save every optimization and de-optimization that happens in the JVM at runtime and save that. And the next time you start up, we just tell the compiler, oh, instead of doing interpretation and all these trying to make it faster, just use this, because this is the best optimization you can do, and then it will be directly compiled down to the best possible code. We have Cloud Native Optimizer, which is similar to the web JIT that is in Semeru, so we can decouple the compiler and run it in a cluster in the cloud, and then you can, instead of compiling locally, you can directly get the compiled code from that cluster, which is way faster. And we have also Azure vulnerability detection in this one. And crack will also come to Prime. So yeah, you see this has a lot of features, which is one of the reasons why it's not free. You have to pay for it because we have to pay our own people to create all this awesome stuff. Takeaway: are all those builds of OpenJDK really different? Technically, not really. It's more or less the same. When it comes to service support and costs, yes, there are differences between them, and it's absolutely worth checking all the different distributions and what is the support for these distributions and how much does it cost and all these kind of things, right? So choose wisely when selecting a JDK. This is my advice. And just don't take something because someone said, oh, we always use that. At least take a look at it and make sure you choose the right one. And at last, I would like to hint you to this book that my colleague Simon Ritter wrote. If you're in the situation where you have to migrate, let's say from OpenJDK or from whatever JDK 8 or whatever to 11 to 17 to 21, if you like, or you just have to go from Oracle and you would like to use one build of OpenJDK, you can check this QR code and then you can get a free copy of that book. It's not really big, but it contains all these little hints that you need to know. It explains what is the TCK. It tells you what to do if you run into problems when you migrate from one JDK to another and stuff like that. So you might want to check that out. And with this, I say thanks for listening and thanks for having me. It was a pleasure and an honor to be part of the conference.
Thank you very much for the presentation. It was amazing. Actually, I never realized the vast amounts of the options. Although they are similar, there are some very interesting optimized builds that you would use, for example, like you mentioned, for Lambda, right? Where if you scale the little win of a few milliseconds or a few seconds even, right, on the execution of millions of Lambda, that, well, comes into the very real difference in the bill that you are getting from your cloud provider, right? You started your presentation, so I have a question here. You started your presentation from the statement about like GRE runtime environment versus JDK, and about people using the JDK in the actual production, which, well, shouldn't be the case for the most of the people, right? Would you say that given that there is this vast number of different builds that are available right now to the developers, it makes sense to use different tools in the development environment that would, for example, speed up the hold reload capabilities or provide additional developer tools versus the production? Or it makes sense to build your application in exactly the same tool set that you would be actually running it in?
Well, that's a good question. It really depends how you set up your system. So even if everybody's talking, for example, about microservices these days, there are lots of people that don't run microservices. They run application servers, and it's totally fine. And they even don't run on containerized environments sometimes. So it's hard to give a general answer. So if you should use the same tools that you use to run your stuff on, or you run it in production. I can say that, for example, what I don't like with the JVM stuff, for example, I like the idea that you can create native images, right? So I use that for command line tools and other stuff, which is great. But what I don't like, and I didn't like that with the GWT, it was the same. You write your code in Java, you compile it into something else, and then you have to debug the something else and not the Java. And this is what I don't like, right? This is if you go this way, then you have to debug native code. And back in the day when it was GW2, you suddenly have to debug JavaScript, and you wrote the code in Java. So these things I don't really like, this cross-compiling to other languages. Apart from that, is usually if you use tools that you use on your development machine, then it's most of the times a good idea to use the same stuff in production, just to make it as compatible as possible and debugging as easy as possible. We are so used to in the Java environment that we have all these tools, right? Tons of different tools, super beautiful IDEs that supports lots of stuff, way better than any other languages have. But that's also the problem. If you have the choice, right, then it's hard to give an advice because there are so many tools out there. But when it comes down to JRE, JDK, and JLink, if you have the chance to look into JLink, you should really do, because it can reduce the size of the runtime. And you know that many people talk about JVM footprint is so big. We have tools to make it smaller, but it seems nobody's using that. And so this is something I would really advise people to take a look at.
Would you say it's a matter of awareness that these tools exist, or it does require kind of deeper understanding of what exactly the resulting runtime should look like? So how much is it awareness versus required skills?
I think, first of all, it is awareness. So because when I ask who knows JLink, nearly nobody shows up and says, yes, I know it. So some people heard of it. So there's definitely an awareness problem with JLink. The other thing is, of course, it takes a little bit effort to get into it, but this is all well documented. It came, and I'm surprised that so many people don't know it, because when they came from JDK 8 to 9, this was everywhere. They said, yeah, if you would like to switch from 8 to 9, you can use JLink to do that. And I was like, yeah, okay, let's try it. I use it sometimes. I also don't use it every time, but especially when you run on containerized environments where footprint matters, then you should take a look at it. So it's documented, it's out there. It's part of the JDK since JDK 9, so it's not really hard to figure that out. But the problem is, and this is something else, people use prepared Docker images that come already with the JDK, sometimes with JRE, this might be one of the reasons. It's easier to just take that instead of tailoring your runtime to your application, right? So they just drag something from some repository and add the application and run it. Right, so this
Well,
is
and it
also
adds the sense of safety, right? You see that this container image has been downloaded 10 million times, and well, 10 million people cannot probably go wrong, right? So you take it and...
But the other thing is, if you talk about safety and security, JLink is also a way to make it more secure, because stuff that is not in your JDK is not available for hackers. So this is also, if you would like to run secure, for example, JLink is also a good idea to use. It has its advantages, and there are reasons why people don't use it, and I get it. But still, I would suggest people should at least take a look at it and see if it has a benefit for them. It won't hurt.
That is a great advice, and I hope that you're still not running too late to your airplane.
No, I now have to run because the taxi is coming in 10 minutes.
Perfect. Then thank you very much. I think that you can follow up with the questions later in the chat. So thank you very much for the presentation. Definitely gave good food for thought, and it was a pleasure to have you in this conference. So thank you.
Thanks for having me.